This podcast is brought to you by VinZero. VinZero pioneers solutions and services to the AEC and manufacturing industries to support net zero targets. Visit vinzero.com to learn more about how organisations design, build and solve through digitalisation. From VinZero to you, welcome to our Think Future podcast series. Each week we'll share conversations with industry leaders from around the world to find out how they're thinking future. Subscribe to VinZero Think Future for access to more episodes, interviews and profiles. Dr. Reza Hassani is a Senior Associate Structures for BG&E, with over 16 years' experience in structural design and construction covering a wide range of architectural and engineering structures in Australia and overseas. Reza has solid technical knowledge and skills in structural analysis, design, value engineering, concrete technology and numerical modelling. This has enabled him to take the lead for BG&E as structural engineers for the Quay Quarter Tower in Sydney, Australia, transforming an existing commercial building into a world-class vertical village. The QQT is a hallmark of world-class engineering and ingenuity and has set a global benchmark for adaptive reuse as well as workplace and mixed-use spaces. Welcome to the program, Reza. Reza, the QUT program is receiving accolades both locally and globally, and BG&E has received some great recognition for its part in the project, including World Building of the Year winner at the 2022 World Architecture Festival in Lisbon. Can you give us an overview of how the QQT project was undertaken from an engineering perspective?
Sure thing. The QQT Tower is a 51-storey commercial tower in Sydney CBD located in Circular Quay. It is an extension to the old AMP Tower, which was constructed in 1976, about 45 years ago. With the new extension, 5 new floors added on top of the building, and the floor areas doubled. To achieve this, the 30% of the floor were demolished on the north side of the building, and the new tower was constructed and connected to the old AMP Tower. The design process started about 10 years ago, but the main part of the design and construction delivery started in 2017 when Multiplex came on board. There were 3 main stages of the design. The first one was understanding the old AMP Tower. To understand the structural properties of the building, we took around 1,500 core samples out of the building. We tested them in the lab and we did some numerical analysis to model the behavior of existing building. The second stage was to design the new tower and integrate it with the old structure. To do that, we developed the 4D structural model, incorporating the time factor in our modeling to estimate the behavior and displacements in the structure. The third part was the verification of the design. Because this structure was very complicated from the structural point of view, and this was the first time in the world that we were doing this, we installed around 11 different instruments in the building to measure the building displacements. This project was very successful because of the genuine multidisciplinary team collaboration, including the development team, architects, construction team, and all the engineers involved in the project.
What was the key objective of the project from an engineering perspective?
The main objective was to retain the old AMP Tower, which was about 45 years old, and add a new structure to that. So if I want to list the main objectives was to addition of the floor area, because that was the developer's aim, retain the height of the building and increase the height slightly by 5 floors. From our perspective, the main one is to ensure that the structure will be serviceable for the next 50 years and make it safe and sound for the occupiers in future. In terms of the architectural features of the building, there are some unique features, including the cantilever floors and hanging columns. So for us as structural engineers, it's a challenge, and we could achieve this by very complicated structural models. One of the byproducts of that construction methodology was minimizing the wastage and saving the embodied carbon during the construction process, because we didn't demolish the existing building when we actually reused the materials that were there for the last decades.
And what specific aspects of engineering make it the world's first achievement And of those, what were the most important aspects to understand during the project?
From what we know, the QQT was the tallest demolition and adaptive reuse in the world at that time. And from that time, I'm not aware of any other project like QQT. The most challenging engineering aspect was the integration between the old structure and the new structure. Because the old structure will not move anymore and it has settled and shrunk during the last decades, on the other hand, the new structure is fresh concrete and new structural steel, which will move in future. And the integration between an old structure and new structure is very challenging. To add to the complexity of this fact, it's the height of the building. If we only had 5-story building, it wouldn't be this complicated, but we have a 50-story building. It is conventional to add a structure on top of the existing structure, but it's not a common methodology to add structure next to another structure. I mean, connecting from side of an existing tower. So controlling the movements in the foundation, in the columns, including the column shortening in the fresh concrete, the settlements was a considerable challenge for us as structural engineers. To be able to verify our design, we did an iterative analysis and design a numerical analysis, and we model every construction stages based on the direction we were receiving from multiplex. So we were modeling the demolition from top of the building and rebuilding the structure from bottom of the building. Then we verified our structural model with the input we were getting from our instruments, the 11 type of instruments that we have installed in the building. We were calibrating the model. We did the model updating in 27 milestones, and we made sure that our numerical modeling is a true representative of the structure behavior on site.
What type of instruments were actually being used during that process?
So the instruments included the traditional positional survey, including monitoring the building displacement laterally and vertically. On top of that, we installed the tilt sensors, we installed inclinometers, we installed strain gauges. Strain gauges were used to understand the movements between the old structure and new structure at their connection point, which was at the core walls. On top of that, we installed a plumb up to understand the building inclination using a very traditional, simple, but accurate method. We installed a weather station at top of the building to understand the wind speed and wind load on the structure at any point of the time. We also measured the damping ratio of the building to understand the occupant comfort and acceleration levels in the structure.
And all of that data was then fed into a digital twin for modelling purposes?
Yes, exactly. So we were receiving data from site on a weekly basis. And if we decided the data is significant, we were entering those data to our digital twin, reassess the structure, and give direction to site to change the design or change the construction stages.
Are you looking for a digitalisation and net zero partner to help you achieve your goals? Join the thousands of AEC and manufacturing customers globally who have turned to VinZero to start their journey toward a net zero future. With 32 offices around the world, VinZero can connect you to the right technologies and workflow processes so you can maintain your competitive position and increase profitability. VinZero has an industry expert to help you navigate the best pathway forward wherever you are on your digitalisation and net zero journey. Visit vinzero.com to find out more. And in terms of upcycling, what was it exactly that you were able to achieve?
The main achievement for us as structural engineers, we could demonstrate that the building can be serviceable for the next 50 years, the existing building. And we also could demonstrate that the new building connected to the existing building or the old AMP tower can integrate very well with the existing building. With this, we could double the floor area in average and also add to the height of the building by about 5 floors. And this was achieved by demolishing the 30% of the tower on the north side. The demolition started from the top side, and the reconstruction of the new tower was started from the bottom side to save the construction time and cost. In terms of the upcycling, this construction methodology helped us to retain the 60% of the existing floor area.
That's a great result. So, how did the design optimise embodied energy or support sustainability and reduce carbon load?
In my opinion, the most important aspect of QQT was retaining an old structure rather than demolishing and rebuilding a new structure. I believe the best way to minimize the embodied carbon in construction industry is to retain the structures that we have at the moment and demonstrate that they can still be serviceable for future decades. With this construction methodology that we use in QQT, we could save about 10,000 tons of carbon, which is equivalent to 12,000 flights from London to New York. On top of that, we could save the construction time of about 13 months. And I'm sure that there is a carbon emission attached to that time, all the transportation and things that people would use to service the job. We haven't calculated those numbers yet. But to me, this construction methodology was a game changer in terms of not thinking about the design methods or coming with the greener materials. It's actually retaining what we have at the moment and showing that it's still safe and sound to use them.
So, looking back on the various stages of the project, what would you say were the key learnings?
To me, the key learning of this project was thinking out of the box. So, if we wanted to use the simple structural design methods that we use on a daily basis, we couldn't really design this structure. So, we had to think out of the box, come up with smart ideas, use the latest technologies or latest design methods, including displacement method, and show that the structure is safe to use. The other one that was really fascinating on this project was the teamwork between all the stakeholders and all the parties, including architects, construction team, and developers and us. We had design meetings on a weekly basis, sometimes twice a week, and people were providing ideas like to build this and how to make it smarter. We were very open to new ideas. We were updating our design and we also are providing input to the design efficiency. To me, that teamwork was also a main factor in the success of this project. The third one, I would mention the use of latest technology that is available at the moment, but traditionally, I think the structural engineers don't like to use the new technologies. But we used BEAM, the Building Information Management System. We used the most developed numerical analysis softwares, and we spend a lot of time to integrate all these softwares together and also coordinate with other engineers, including services and architects.
So you're mentioning there that some of the industry doesn't necessarily like to use all these tools. How important do you think digitalisation and these types of technologies are to enabling the type of collaboration required for projects of this nature?
In my opinion, it's really important, especially these days with numerical modeling and digital twinning or BIM management. You can actually simulate the structure with every bits and pieces in computer and do your clash detection, do your construction staging, see what's the smartest way to do these things. I think the latest technologies, including virtual reality, will change the game because I've seen some industries working on these aspects, but the construction industry is falling behind. The developers, they're catching up. Actually, you can go to site and put on your goggles and see what will be the final product.
So just as a continuation to that, how do you think engineering has changed, say, over the last 10 years? And with this type of project in mind, given that it was the first type of project that BG&E have undertaken of that nature, do you see that there will be more projects of this nature moving forward?
Yeah, as I mentioned before, the carbon saving in this project was one of the key aspects. So structural engineering, in my opinion, is a bit behind at the moment. However, we can see some momentum in the industry. Previously, the main focus was on the optimization of the material itself, including steel production or concrete production. But after doing a successful project like QQT, we could show that reuse or upcycling of the structures is also an option. And maybe it's a smarter option. I think doing research on greener materials is good, but we also should think about adaptive reuse of structures as well. I know that in some countries, it's mandatory to calculate the embodied carbon, like UK, and there is a target to achieve net zero by 2030 or 2050. I know it's debatable, but at some stage. And I know that Australia definitely will catch up. At the moment, there is no legal requirement, but we are working with UK requirements at the moment. We're trying to reduce the embodied carbon structure by using greener materials, but also doing smarter designs and maybe retaining the existing structures and adding to those structures.
So in terms of the importance of the uptake of technology for companies that are slow to adopt in your industry, what would your advice be to those companies in taking it on?
I think the reason that some companies are slow, it's the cost and the training. But I would recommend that if they spend some money up front, they will see the benefits very soon and they will come up with very successful projects, time and cost effective. I think it's an investment up front that you invest on new technologies, you train your engineers and employees, and you come up with a more efficient team which can do smart designs and win more projects.
And Reza, as we close off our conversation today, one of the questions I always like to ask our guests is how they think future. So when you think future about engineering, what is it that excites you the most?
What excites me the most is the change, and it's a good change. It's a positive change. We need to change the way we think about structural design. It's not like the traditional design of columns and beams. We need to come up with some smarter ideas. We need to try and use the existing structure rather than simply demolish and rebuild, because it's against our environment. I'm very excited with the net zero targets. I believe it's possible in our industry to have some structures that actually have positive effect on the environment, not a negative effect. But to achieve all these great targets, we need to work with all the parties, including architects and mechanical engineers, and also government, because they should focus and invest on these great outcomes. Also, this could not be achieved without using the latest technologies. We should upspeed our, I would call, digital skills. We have a lot of great technologies out there, but we don't really use them. We have the AI, we have the ER, but the structural engineers are falling a little behind. We should catch up, see a momentum, start using them very effectively in our structural design. And that really excites me. Every time I see some new development in structural softwares, a new way of design, it shows that we're moving toward that great outcome.
Well, Reza, thank you for sharing your enthusiasm for the change across industry, and we wish you all the best with the continued success of BG&E adaptive reuse projects in the future. Thanks for joining us.
Thanks very much, and I do appreciate it.
This podcast was brought to you by VinZero. VinZero help the AEC and manufacturing industries keep pace with digital change and achieve their technological and sustainability leadership goals. VinZero is a company that cares about creating and building a better world. Together, we are working with industry and environmental experts, providing forums and platforms through our VinZero Think community to create conversations that matter to our future generations. We invite you to join in the conversation and participate in our Think community. Like and subscribe to Think Future to stay up to date with the latest innovations and conversations as we take AEC and manufacturing around the world closer to zero. You can download our podcasts at vinzero.com or from your favourite podcast platform. From VinZero Think Future, thanks for listening.